The idea. Components, 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 components. What you need to realize is that as soon as I add a sideways motion, right away you're going to break things up into horizontal and vertical. And right away, as long as you're on the Earth, and I won't give you any weird ones like being on the moon, I did in the homework because I'm a nerd, but not on your test. Right away you can say, what goes there? What's the horizontal acceleration of a projectile?
0.
Okay, that you have to have memorized by now. Hopefully you do. Good, 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 good. What's the vertical acceleration of any projectile on the Earth? Negative 9.8. The other values will change depending on the type of question, the type of projectile question that I can give you. Okay? The first one that we did, day one, was just straight vertical. There was no horizontal component, which meant I could ignore the entire horizontal column. As an example, something like this. Give me a second. This is what we called freefall, which we did earlier this year, but I didn't do freefall from a cliff necessarily. So freefall from a cliff, your vertical is either going to be going straight up, or if I drop it, what's your initial vertical velocity? No, if that's your acceleration. If I drop something for a split second before it leaves, right when it leaves my hand, it hasn't started falling yet, it's going to be 0, and you can take it from there. As an example, something like example 2. Okay? I'll pick this question here. Gonna work. Hey, it is pasting. Maybe. Hey, it did. Except, let's change it. 18 meters per second. Okay. And it says, how long does it take to reach the top, and what's the maximum height? Both totally fair questions, and kind of nerdily interesting ones. I like projectiles. I'm always interested in, really I can calculate this, and we found with that lab with the cup, we could be fairly accurate. Most of you actually hit the center of your cup, or you hit the lip of the cup because it was coming in at an angle, but you were pretty close. Remember that one? You gonna make it, Kelly? That was 3 yawns in a row there.
No.
2 yawns in a row there.
There's just one.
It was just one elongated, very long, kind of a hit pause and then go. Okay, so you kind of do a yawn. Okay, cool. Normally I'd say dulp. There is a picture. There is no horizontal this time, so I'm just going to go vertical. What do we know? First thing I can write vertically is, then it depends on the question. I almost always want to try and find my initial vertical velocity. There's several possibilities. If we're dropping, what's my initial vertical velocity for a split second?
0.
You said it before, right?
Yeah.
0. If I launch horizontally off a cliff, my vertical velocity is also still going to be,
0.
because that's just like dropping something. Yes, you're moving horizontally, but they're completely independent of each other. If I launch it upwards, my vertical velocity in this case will be, my initial vertical velocity in this question will be what? Read behind me. 18, right? And up, because it's so positive. If it's at an angle, which we'll do later, you never actually use that. You go components and use the components. Okay? What do they want me to find in part A? Time. To when?
How long it takes to reach the top.
So what I've told you is for all of these, 2 pieces of information is not enough. You need a third piece. And one of the tricks that we can use if it says time to the top is we know something vertically at the top.
Yeah, the 0.
Yes. I might perhaps have my formula sheet in front of me, unless I have it memorized. Because now I'd be looking for an equation that had A, V initial, V final, and T. And you'll notice I've made sure everything is vertical. Y. Time I don't care about, Dylan, because it's a scalar. Which equation am I going to use, first of all, as a starting point? Go ahead.
Vf equals Vf
Yep.
plus At.
Can you get the t by itself in your head?
T equals
Ah, look at her go.
Vf minus Vi over A.
And double check. I'm putting in a vertical, and a vertical. The big mistake is kids want to put verticals into horizontals and vice versa. Now it's fairly plug and chug. It's going to be 0. You understand why it's 0 for a split second at the top, right? Because it does come to a stop for a split second. Minus 18 divided by negative 9.8. And then it's calculator. 0 minus 18 divided by negative 9.8. By the way, for time, should I get a positive answer or a negative answer?
Positive.
Should. 1.83 seconds. 1.84 seconds, Mr. Dueck. Okay. By the way, are we starting on the ground in this question? Look at the picture. Yes?
Yeah.
Are we ending up back on the ground in this question? I think so. What goes up must come.
Down.
So I know something else. What's the final vertical velocity right when I hit the ground? Not after. Negative 18. What's the time of flight, total time? I could use a negative 18 right there, or I can just double this one because what goes up must come down. When can't I use that trick? Cliff. Because you're going to go up, but then you're going to fall down for longer than you went up for. So I can't just use the whole double the time trick, and I can't say, oh, it's going to be negative 18 because it's going to speed up when it falls past the cliff and go faster and faster and faster in the negative direction. But ground to ground, I can use those tricks too, to find whatever they ask. In fact, what's B asking me to find?
The maximum height.
That's a distance. Yes? That's a vertical distance, as a matter of fact, a dy. And I got several options. I could use VIT plus a half AT squared, where VI is 18. T is the answer from part A, because that is at the top. The only reason I might choose not to do that is because I am using the answer. You know what, though? Are we near the end of the course? I think we can start to trust that we found a previous answer correctly and use that. So you could simply plug that in. Oh, what would I use for A vertically? Negative 9.8. And now it's straight plug and chug. Type into my calculator. If you didn't want to use time, because you're like, what if I got it wrong? You could use and get the D by itself. How would I get the D by itself here? Dylan, take a stab. Give you a hint. Yeah, I got that.
E equals VS
Squared.
VS squared minus VI squared divided by 2.
Look at you. Remember how this was tough at the beginning of the year? Now you're like, oh, Dueck, I can do this almost in my sleep. I was sleeping before. And go from there. What else could I ask from the ground level straight up? I could say, find the velocity after 1.2 seconds. All I would do then is I would use V final equals V. In fact, hey, let's add a part C. By the way, how many seconds was it to get to the top? 1.84. Is it on the way up after 1.2 seconds or on the way down?
Yeah.
Up. So you know what? Just for fun, let's go 2.2 seconds. On the way up or on the way down? Should I expect a positive answer or a negative answer here when I find the velocity? Should. Okay, what can I use? I think I can use positive 18, my V initial, plus negative 9.8 times 2.2. And I think you will get a negative answer telling you it's on its way down. What if I put 1.84 in for T? I should get 0, or really, really close to 0, because I think that 1.84, I rounded off a little bit. But I should get, yeah, 1.84 seconds. It did come to a stop for a split second, or really, really close to that. Okay. That's straight up. horizontally off a cliff was the next thing that we did. Okay. That's when we now had a horizontal and a vertical component. So we're talking about this. Making up numbers. 19 meters per second. And let's suppose they told you the height of the cliff was 112 meters. Okay. What can I ask? Before I decide what I can ask, right away, as soon as I see this, I have a horizontal motion, and I'm also going to be in free fall. This is where I would say to myself, self, what can I write right away?
AX equals 0.
Darn right. What else?
AY equals 1.3.
Absolutely. Two more things.
EX equals 9.
Nice! And?
DY equals
Not yet.
DY equals 0.
Ah! That's why, have I said underline the word horizontally? What I'm really trying to do when you do that is to think, remind yourself, I know my vertical velocity. They don't have to tell me that. I know for a split second it's 0. Then it depends on the question. That I would write horizontally off a cliff no matter what. Then it's going to depend on the rest of the question. And in this case, they gave me a dy. And don't tell me it's 112, because it ain't.
Negative.
Why negative? Because we end up below from where we started from. Now I'm committed to which column, which approach I'm going to use, because in only one column do I have three things. By the way, the other thing they could have done, they could have given me the range, which I would call dx, I would have put here, and then I would have said, oh, I'm going to solve it in this column. Both times, both situations, almost always, they're asking me to find the time. And in each case, in fact, I'm going to say part A, in each case, the equation is the same. We're going to use d equals VIT plus a half AT squared. The starting point is the same. If I'm doing this vertically, Vy initial is 0. That'll cancel, and I'll end up with d equals a half AT squared to get the t by itself. And you get FD with a squared. If I'm solving it horizontally, if I knew dx, that whole thing would cancel. I just have d equals vt, get the t by itself. Oh, divide by v. That's a little easier. But either of those is going to be fair game. In fact, I think I might have done one of each on the test. One cliff where I tell you the height, horizontally launched. One cliff where I tell you the range, horizontally launched. Okay. Or the only other thing I can really do this year, I can tell you the time. But if I tell you the time, kind of falls apart. We did one like that on quiz number 3. If you have time, then it really becomes fairly plug and chuggish. Oh, if I know the time and you want to find the range, plug the equation into there, put a 0 in for acceleration. If you want to find the height, plug the equation into there, put a 0 in for VI. Meanwhile, based on this question then, we're going to have an a t squared. I could put a 1/2 in front. Here, I find it easier, McKenna, to do that. Why? Because what am I trying to get by itself? What did they ask me to find, kiddo? What did I ask to find in part A? T. So I want to get the t by itself. See where it is on the right-hand side of my equation? What's right in front of it? What letter? How would I move that over? What's the a doing to the t?
Timing, so you divide it.
And underneath the t, what's there right now?
A 2
Dividing, so how would I move it over?
times
And then I'd have a squared. How to get rid of a squared? Go ahead.
t equals e divided by 2 square root. And that equals
I think I might have heard you correct. It's going to be t equals. You got that right. Woohoo! Shut up, mister. There is going to be a square root. It's going to be 2 times d divided by a, right? Because you times, you divide, and then you'd square root. Is that okay? Oh, and I always just remember vertical, vertical. Making sure my vectors are matching. Let's crunch the numbers. So I guarantee you're going to have at least one question where I give you a cliff, a horizontal velocity, and I give you the height, and I say, yeah, find the time of flight. And you'll do it just like this. Oops, what did I forget to do? I was going 22 seconds. That's a long time in the air. Yeah, no kidding. When I jumped out of the airplane, I think I only was in free fall for like 20 seconds, and that was really high. Don't forget the square root. 4.78. As an answer, if this is what they wanted, I would probably write 4.8, but somewhere I would jot down probably 4.781 or 4.7809, and that's what I'll use for further calculations as a more accurate, less rounded off value. Yes? What else can I find? Well, I guarantee on your test tomorrow, I'm going to say, find the range. What do I mean by the range? It's a distance. Which one?
What do you mean? Which one?
See my T-chart?
DX?
Horizontal dx. Yeah. 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 How far sideways it went from the cliff. Okay. Oh, what did I just find in part A? I would probably then walk up to here and I would say time equals 4.78. Ooh, but I can also write that in this column because the amount of time it takes to hit the ground vertically, that's exactly for how long it's traveling sideways. Yes, 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 yes. How many things do I have now in the horizontal column? 3, which suggests that I can find any fourth. And what did you tell me we're finding, Kelly, my angel, joy of my heart?
DX.
So I'm going to write over here dx equals question mark. And we already said that ax was 0, vx was 19, I've forgotten. Was it 19? Yes, it was. Oh, and t is 4.78. So I'm looking for an equation that has d, v, a, and t. And by the way, you'll notice I didn't bother putting an initial right here because what's my acceleration? Horizontally, 0. You could put initial. It's not wrong. It's just, if it's not going to change, I just like to remind myself, oh, that velocity is going to be the initial, and the final, and the middle, and the average, and the horizontally is not going to change. Which equation am I going to use here?
D equals dt.
Oh, she even, yeah, nice. D equals VIT plus a half AT squared. And did you hear her, McKenna? In her head, she said, that's going to be gone. Why? Because A is equal to 0. So it's going to be 19 times 4.78. Yes?
90.82.
Oh, she's way ahead of me. Not probably 90.82 if you use the 4.78. I kept my value on my calculator, so I got 90.83. 90.8 to 3 sig figs were both good anyways. And that's meters. You guys okay with that? What else can I ask? Here would be a tougher question. What are we on? C? Find the velocity, magnitude, and direction after. Now, I could either do it right when it hits the ground, in which case t would be 4.78 seconds. But I'll pick a different time, less than 4.78 seconds. How about 3? Is that okay? That's the question. Now you need to visualize what this looks like. When we launch this horizontal projectile, it's going to go like this. Without hitting the chair. Nice try, dude. It's going to go like this. And I think after 3 seconds, it's going to be kind of heading kind of like that. Is that okay? After 4.78, it will be a little steeper. Right at the beginning, it's a little shallower. It's getting, the velocity vector would be looking like that. Where did it end up? You see? Ah, over here. People are home are going, like what? I just tossed the ball horizontally for those of you who are watching at home. So, I'm going to draw a picture of what that looks like in my mind. I'm going to say, you know what? I don't exactly know the details, but I'm pretty sure after 3 seconds the velocity kind of like that. Maybe steeper, maybe shallower. I don't care. I'm doing kind of a generic and a nice big long one so I can draw a good triangle. Because I know what that velocity is made up of. It's made up of a horizontal and a vertical. I know the horizontal because that never changes. Was it 19? I think it was, yeah. What's the vertical? I don't know, but I can find it. I can say V final, V initial, plus AT. Again, McKenna emphasizing vertical, 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 vertical. Where the initial was 0 right when it left the cliff. Good old negative 9.8. And the T they gave me was 3 seconds. The vertical velocity, the vertical component of the velocity is going to be negative 9.8 times 3 plus 0. But is that going to change anything? No. It's heading down at negative 29.4 meters per second. 29.4. Where'd the negative go? It's in the arrow pointing down. Oh, if I'd given you the same question, McKenna, but instead of saying find the velocity after 3 seconds, if I had instead said find the velocity at impact, you would use a time of 4.78 right here, and you'd get a different vertical velocity, but your horizontal wouldn't change. Now that gives me the two components. How can I find the actual resultant velocity? Pythagoras for the magnitude and trig for the theta. Right? Pythagoras is going to be, the resultant squared is going to be 19 squared plus 29.4 squared, and then square root. 19 squared plus 29.4 squared. What happened to the negative? When you square the negative, it's going to vanish anyway, so I got sloppy that way. Square root. Oh, that's a fluke. Almost worked out bang even. In fact, you know what? To 3 sig figs or to 2 sig figs, it is 35 even. 35. That's the magnitude. And what else did they want me to find?
Direction.
Direction. Which way is the direction? Where this velocity is coming from, right here. There's my angle. How big is that angle? Well, opposite, adjacent. By the way, I could use the 35, but again, because I'm worried I might have got it wrong, I'll try and use the data that they gave me, right? Tan, what you did this weekend. Some of you burned. Tan mystery angle equals opposite. Have you guys become pretty good at trig, by the way, compared to your grade 10 year? Yeah? Most of you are almost doing it like, tan. How do I find an angle? Second function or shift or, yep, good. So this is my argument. I think we should do more applied stuff in the lower maths as well, because I think you get far better at trig applying it here than you do with all the dumb pictures they give you in math 10 and say, solve for x, solve for x, solve for x. How about solve for velocity or something that means something? Anyways, end of rant. McKenna, did you get 57 degrees? 57.1 degrees?
Yeah.
Yep. So we'll go at 57 degrees. What did we call when we were heading down? Remember the phrase? Because I can't call that south of east because that would mean up was north. And up is not north. That way is north.
Below.
Below what?
The horizontal.
Yeah, the fancy phrase was below the horizontal. Can Can you see it? Here's the horizontal, below the horizontal. What if you're on the way up, above the horizontal? But that wouldn't happen being launched horizontally off of a cliff. Is that okay, Dylan?
Yeah.
I think there's going to be one of those on your test. I think. Can't remember. I photocopied the test like 2 weeks ago. Okay, so there's definitely going to be cliff, horizontal. And I've told you I may give you the range or the vertical distance. Use it to find time. Still the same equation. D equals VIT plus a half AT squared. Something's going to cancel in that equation. And then go from there. Be very careful with your horizontals and your verticals. Is that okay, McKenna? Okay. Let's go off the ground at an angle. Oh, so definitely A and B, I guarantee is on your test. Or I give you the range, in which case B would be find the height. I think that's on your test as well. I'm pretty sure C is as a nasty challenge question. The third type is from the ground at an angle. As a picture, that. So let's make one up. Pick a number between 50 and 100, McKenna.
50.
Pick a number between 20 and 45, Kelly.
38.
There. Our velocity is 50 meters per second above the horizontal at 38 degrees. I'm going to go components, and I'm never going to use the 50 again. Kids want to use that 50 as the initial velocity. No, 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 no. It's the initial slanty velocity. If you're doing slanty math, go ahead, but we're not doing slanty math. We want to deal with only vertical or only horizontal, but never both at the same time. So you give me this. In fact, I'll tell you what part A would be. Part A would say, except spelled properly. So you would say, all right. Now, if I hadn't given you the dolp, you would dolp yourself. Yes, draw the picture yourself. And you go, okay. This one here, Vx or Vy, what am I going to call it?
Yeah.
Vx. What about this one here?
VY.
Nope. Vy what?
I.
Why? I want to remind myself that part's changing. Why didn't I put an I on the X? It's not changing. And any chance I can get to remind myself of the key concepts, which I said at the very beginning, I'll use that. Based on this angle here, Vy initial, opposite adjacent or hypotenuse.
Opposite.
How about the 50?
Hypotenuse.
Which trig function?
Sine.
We end up with sine 50 equals sine 50. I did it again. Sine 38. I've done that 3 times in a row now on that question. Man. Now I'm getting a complex. In fact, Vy initial is going to be turns out Vy is 50 sine 38. If there was some dumb easy way to remember that, it would be helpful, but I got nothing for you. I worry that there's still some kid who hasn't got the hint and still hasn't, well, whatever. Okay. Vy, what sound is that?
Oh, okay, now I got it.
Just Y and sine kind of rhyme. That's how that's how I've remembered it for years. Now that only works for the velocity. Some of the other component things, and if you take physics 12, we look at other components because stuff is at different angles. That won't always work. But for velocity, yeah, Vy sine. Oh, and then Vx, what's the opposite of sine?
Close.
Cos, yeah. Tan is not the opposite of sine. Tan is the weird one. It's cos is the other one that has a hypotenuse in it. So Vy is sine Vx. Thank you for fessing up and asking. Now you know. It's going to be 50 cos 38. 50 cos 38. Oh, nice. 39.4. 0, 0. You know what? 39.4 is rounded off nicely then. Don't forget the units if I actually ask for that as an answer. And Vy is sine 30.7830. I'm going to write 30.783, but then for my answer, I'll round off to 30.8. But I'll use 30.783. That's a nice place to round off because there's a 0 there, yes? Equals 30.8 meters per second. I'll even put little boxes around these for Mr. Dueck so that my answers stand out. Now that we've done that, it's completely the same as all of this combined. It's the same as example 2 that I did with you in Freefall, except, oh, there's a horizontal component. It's not quite the same as horizontally off a cliff because Vy is not 0. Vy initial is 30.783. But I'm going to start out with a t-table for whatever they ask me to find. What could I ask you to find? Somewhere over here I'd say, okay, horizontal, vertical. What am I writing for Ax, McKenna?
0.
For Ay? Negative 9.8, she says with boredom and disdain in her voice. Oh, and what am I writing for Vx and Vy initial? What am I writing for Vx, McKenna?
39.4.
Tis. What about for Vy initial?
30.783.
Nice. I'll use that. That's not enough. There must be something else. Okay. Can you read B to me, McKenna?
Times the top.
To the what?
Top.
Top. I'm thinking vertical, right? Top and...
Y finally equals 0.
And in fact, we'll use the good old Vf equals Vi plus At, but get the T by itself. We'll get T equals Vf minus Vi over A, but make sure you use vertical, vertical, and vertical. Oh, one of those will be 0. The Vf final is 0. V initial, not. Divided by negative 9.8. Are we starting on the ground and ending on the ground? I think this question is. So if I said to you, find the total time, you could just double this. Or you do know Vy final. What was Vy initial?
30.7.
What's Vy final just before it hits the ground?
Negative
30.7. So you know that as well. That can come in handy. Okay. Did we get an? You know what? I should crunch the number. So it's going to be 0 minus 30.783. Did you crunch the number, Kelly?
Yeah.
What'd you get?
3.14.
I made up a question where the answer is pi? Are you serious? Wow. That is too cool. I got to see how close I am. I was going to use your answer, but 0 minus answer divided by negative 9.8. Do I get that if I... It is 3.141. I even got the fourth digit, the fourth sig fig. Oh, man. So 3.14. Nah, that's technically not right. Haven't you ever wanted in a restaurant to leave pie as a tip, though? Right? So as much as I'd love to write down that t was equal to pi, 3.14, I'll go 3.141, and then I'll put equal 3.14. In fact, I'm going to go 3.1411, 3.14, or even 3.1 seconds. I'll also ask this. By the way, what's the vertical displacement of this projectile? How high is it when it starts?
30.
How high is it when it starts?
0.
How high is it when it ends?
0.
0. What's the vertical displacement of this projectile technically?
0.
0. Horizontally, it's traveled. Vertically, mathematically, didn't go anywhere. Yeah, did some stuff in between, but didn't go anywhere. Horizontally, sure. So let's find the range. That's a dx. Well, we know that ax is 0. Yes, McKenna? And we know that vx was 39.4. What we need is t. We got two options. We could, because we're starting ground and ending ground, we could just the answer from b times 2. Or if you didn't trust that answer, you're a little you could say I could find total time of flight by letting vy final be negative 30.783 and then use this same equation. And you'll also get 6.28. Let's use b times 2 in the interest of time because you guys get a little squirrely on me. So it's going to be 6.28 seconds, 3.14 times 2. So the range is going to be, well, it would be vxt plus a half at squared technically, but what's going to happen to the half at squared? Gonzo. So it's going to be 39.4 times 6.28. So I have this time still stored. I'm going to go times 2. There's my 6.28 times 39.4. 247.5, 248-ish, 247. I'd probably take both meters. That's a good chunk. That's a good throw. 2.5 football fields. Probably not thrown by a person. That's pretty much it. So now, any questions from the reviews or anything that you're wondering about? Because they're all going to be variations of this.
Number 6.
Number 6, love to. Oh, where's my review, Mr. Dueck? It's called Projectiles Review. There it is. And I haven't made up an answer key for it yet, I notice. Nombre 6. Nice. It's just what we did. What do you want to do, A or B?
A.
Okay. B, by the way, do you notice the diagram looks an awful lot like this?
Mm-hmm.
Okay. So we're going to go through it, but I'm going to have you talk me through most of it. Where the velocity, come on. Really? I'm trying to delete that screen clipping taken. Whoa! Okay, now we're good. Happy Joy? I guess this is 45 degrees. That's my initial velocity, but is it at an angle?
Yeah.
I'm never going to use it for the rest. I'm going to do components, and then that 100 is never going to appear again, even though it's a nice tempting number. So the first thing I would be doing is I would be saying I got Vx, I got Vy. To be honest, the first thing I would be doing is drawing that triangle a little bit bigger. I think it's a little small for me, but that's just me. We're going to go right. Right? Oh, and I think, Kelly, Vx is going to be 100 cos 45. Vy is going to be 100 sine 45. Now, a 45-degree angle is exactly halfway to 90. I think the result of that is going to be both these answers are going to be the same. Because I think if you draw a 45-degree angle, both side lengths of the triangle, it's an isosceles triangle, if you want the fancy word. I'll double check that really, really quickly, but I'm pretty sure I'm going to go 100 cos 45. And if I go 100 sine 45, yeah, 70.71. Did they ask me to find Vx and Vy as part of the question? Did they specifically say find them?
No.
Then I'm going to write a few extra sig figs and not worry about sig figs in my answer or anything like that. So I'm going to go 70.71. Is that okay? Why did I put an initial on the Vy and not on the X?
Because the Vy is changing.
Okay. So that, we start, and by the way, I'll give you marks for that. Now, what's the first thing you wanted us to find?
Time.
Can't yet. There must be something else that I know.
Vi is 0.
Vi is,
VF.
first of all, vertical or horizontal? What are we talking about for me so I know what column we're under?
Vertical.
Okay, vertical. What are you going to suggest?
VF is 0.
VF is not, VF is 0 after it hits, but that doesn't help me. What is VF, McKenna? Vy final.
70.71.
How come? Because what goes up must come
Down.
down, and we are ground to ground. That's the key to solving this. To realize not 0, that's, by the way, most common mistake kids want to say, isn't V final 0? That's after impact, but not right at impact. Otherwise, it would come to a stop just before it hit the ground and just hover there forever. That's not how stuff works. Vy final 0. No! You got me doing it. Vy final negative 70.71, and now I can find T. How?
T equals.
Oh, she's getting it by itself?
VF
Yes.
Minus Vi.
Nice, nice. It's going to be negative 70.71 minus 70.71 all over negative 9.8. Let's make that a little neater. I'll miss your jokes, Mr. Dueck, but not your handwriting. Yeah, I know. Do I need to square? Nope, no squares or anything. 14.43, 14.4 seconds. What's the second thing this question wanted me to find?
Range.
Did you say dx? You did? Oh, by the way, can you find the range from here now too? Yep, dx equals vxt plus a half, oh no, not plus a half, at squared, because a is 0, and away you'll go. Is that okay?
Yeah.
Yep, give me one like that on your test.
Okay.
Okay. Different angle, probably. I'm not a big fan of 45 degrees, because you get the same answer for both x and y. If you screw up the sine and the cosine, you'll still fluke out until get the right answer, so. However, it's why if you're trying to throw something and you want to get it go as far as you can, the best angle to throw it at is what angle? 45 degrees. That'll give you the longest range. Anything higher will go shorter. Anything lower will also go shorter because it won't be in the air for as long. Since you were wondering, maybe. Next, Kelly? Or anyone else? Any other questions? That was it? That was good? You good? Yep. So that's your homework tonight. Or tomorrow if you have a study block in the morning. Although that's putting it off a bit. Or do you have any block E? Block E? So if you have a block F study block, you'll still be okay. If you don't, then you got some homework tonight. Yeah, Lord of the Flies. I used to think it was wrong, and then I started teaching high school kids, and I went, oh, yeah, if I left them alone, maybe they would rip each other apart. Who knows? Let me just hit pause, and then who wants a copy of this tutorial? Let me do that.